In this video, we're going to talk about P-series. P-series is a special case series, and it's one of our favorite ones because it's pretty easy to tell whether they converge or diverge. So the first thing we're going to talk about is the divergent P-series. Now, the divergent P-series is when you're in the form of 1 over k. Now, notice 1 over k is k to the first power, and that's the key. If k is to the first power, then that's called the divergent P-series or the harmonic series, and it automatically diverges no matter what. In the second example, now we've got the same thing, only now we have some unknown power for k. If p is greater than 1, then your series is going to converge. That's because the fraction is going to get smaller and smaller and smaller if your exponent's greater than 1. If you've got p being between 0 and 1, including 1, because including 1 is the harmonic series, then your series is going to diverge because your denominator is going to get smaller, which means the value of the fraction is going to get larger. This is called a hyperharmonic series. Now, the hyperharmonic is a general classification including both converge and diverge. So the divergent P-series or harmonic series is a subset of hyperharmonic. So let's take a look at a couple and see what we can do. Converge or diverge. Well, if we look at this first one, you can pretty much on these ignore the back term. So if we ignore the back term just for a moment, notice it says 1 over k. K is the divergent P-series, so this thing will diverge. In our second example, if we take that same strategy and we kind of ignore the back term, now p is 3. Since p is 3 and 3 is greater than 1, this one is going to converge. Since it's not geometric, we can't find the sum, and since the bottom doesn't factor, it's probably not a telescoping series. So probably just enough to say it converges. In our third example, the 3 we can of course pull out front. So if we take the 3 out front, now we're back to 1 over k plus 4. We can ignore temporarily the 4. This is the divergent P-series, so diverge. In this back one, again, same idea, pull out the 5, you get 1 over k squared minus 2. Now that this is a subtract sign, we really start to look at whether it's telescoping or not. This one could factor if you had square roots, but I don't think this would cancel out, so we're going to say it does converge. Since the directions did not say find the sum, I don't really particularly care whether it's telescoping. It might be.